Hello, my name is Wan Nazram Fiti bin Wazulkifli. My matrix number is 073780. So today my group will present about performance characteristic of two-level memory system. So this is introduction. Data is stored in two levels of memory using a two-level memory system, sometimes referred to as a cache memory system. In computer architecture, on the processor's chip, the first level, also referred to as the cache, is a compact quick memory where data that is frequently accessed is kept. The motherboard's second level of memory, also referred to as main memory or RAM, is a large, slower memory than that house data that is used as frequently. Two-level memory system's goal is to boost computer speed by cutting down on the time needed to access data. When a piece of data has to be accessed, the processor first check the cache to determine if it is already there. The data can be accessed fast if it is in the cache, allowing the processor to carry on with other tasks without having to wait for the data to be retrieved from main memory. It will take longer to get data from memory if it is not already in the cache. It is crucial to take into account the cache hit rate, cache miss rate, cache size, cache associativity, and cache replacement policy among other performance aspects of a two-level memory system. The system's overall performance and the speed at which data can be retrieved are both influenced by these qualities.
Hi, my name is Muhammad Hafizuddin bin Rosli. My metric number is 072801. So I will talk about cache memory performance. Cache memory performance is the speed at which data may be obtained from the cache and how well the cache works to cut down on the amount of accesses to main memory are both referred to as cache memory performance. Performance of cache memory can be affected by a number of factors, including cache hit rate, cache associativity, cache miss rate, and cache size. Cache hit rate is the percentage of the time that data needed by the processor is found in the cache. A high cache hit rate means that the processor can access data quickly, which improve overall performance. Number two is cache associativity. Cache associativity is the refers to the way that data is mapped from main memory to the cache. A fully associative cache allows any block of data to be stored in any location in the cache, while a direct map cache only allows specific block of data to be stored in specific location in the cache. Fully associative cache generally have a higher cache hit rate, but are more expensive to implement. The number three is cache miss rate. Cache miss rate. This is the percentage of time that the data needed by the processor is not found in the cache and must be retrieved from main memory. A high cache miss rate means that the processor must wait longer to access the data, which can decrease overall performance. The last one is cache size. The size of the cache determines how much data can be stored in it. A larger cache can store more data, which can increase the cache hit rate and improve the performance. However, a larger cache also requires more space and may increase the cost of the system. That's all.
Assalamualaikum. My name is Muhammad Muaz Ramzi bin Muhammad Ramzi. My metric number is 070445. So we go to types of cache memory. Cache memory has three types. First is level 1. This level 1 cache is the smallest and fastest type of cache and is located on the processor chip. Level 1 cache store frequently accessed data and instruction and is used to reduce the number of access to main memory. So Second type is level 2. This is largest, slower, and this is a largest and slower cache located on the motherboard or processor chip. The function of level 2 cache is stores less frequently accessed data and instruction and used to further reduce the number of access to main memory. So last of cache memory is level 3 cache. Level 3 cache is even largest slower cache that is sometimes used in system with multiple processors or high-end servers. The function of level 3 cache is stores data and instruction that are accessed less frequently than those in level 1 and level 2 cache. Thank you.
Okay, Assalamualaikum. My name is Muhammad Haziq bin Muhammad Mazri. My matrix number is 073619. I will be presenting about cache memory management. Cache memory management is the process of controlling data in a computer system cache memory. Cache memory management aims to boost system performance by lowering the amount of main memory access and raising the cache hit rate. To manage cache memory, a variety of methods can be applied, such as data prefetching, cache coherency, cache replacement policy, and cache partitioning. Data prefetching is technique involve predicting which data will be needed by the processor and preloading it into the cache before it is actually requested. This can improve the cache hit rate and reduce the number of access to main memory. The second, cache coherency, is the process of ensuring that the data in the cache is up to date and consistent with the data in main memory. When data is modified in the cache, it must be written back to main memory to maintain coherency. The third, cache replacement policy, is when the cache is full and a new piece of data needs to be stored in it. The cache replacement policy determines which data in the cache should be replaced to make room for the new data. Different replacement policies such as least recently used, LRU, or first in first out, FIFO, can affect the cache hit rate and overall performance of the system. Lastly, the cache partitioning, that is a technique that involves dividing the cache into separate sections, each with its own replacement policy to optimize the performance of the system. And then since it can dramatically reduce the time it takes to retrieve data and enhance system performance, efficiently managing cache memory is essential for enhancing computer system performance. That's all for me.
Assalamualaikum. The given matrix number is 072675. My name is Muhammad Ikram Rafiq bin Suhaid Animi, and I'm going to talk about the advantages and disadvantages of cache memory. So there are 5 advantages of cache memory. First is improved performance, reduce memory access time, increase memory capacity, energy efficiency, and cost effectiveness. So let's talk about improved performance. Cache memory is faster than memory and can significantly improve the performance of a computer system by reducing the number of accesses to main memory. This can reduce the amount of time it takes to access data and improve the overall speed of the system. Secondly, let's talk about the reduced system memory access time. Cache memory is located on the processor chip, which allows data to be accessed more quickly than if it was stored in memory. This can reduce the amount of time the processor must wait to access data, improving overall system performance. Thirdly, increased memory capacity. Cache memory allows the system to store more data than would be possible with main memory alone, as it can store frequently as data that would otherwise need to be stored in main memory. This can increase the overall capacity of the system and allow it to handle more data. Energy efficiency means that the cache memory requires less power to access the main memory, as it located on the processor chip and does not require separate memory modules. This can help to reduce the power consumption of the system and improve energy efficiency. Last but not least is the cost effectiveness. Cache memory is generally cheaper than main memory, as it requires less space and fewer components. This can make it more cost-efficient solution for increasing the memory capacity of the system. Now let's talk about the disadvantages of cache memory. There are 4 here: limited capacity, complexity, data consistency, and cache tracing. First, limited capacity. Since cache memory has a limited capacity compared to main memory, as it is designed to store only frequently accessed data, this means that it may not be able to store all of the data and instructions that the system needs, and may need to be accessed more frequently to retrieve data from main memory. Secondly, the complexity. Cache memory system can be complex to design and implement, as they require specialized hardware and software to manage the data stored in cache. This can increase the cost complexity of the system. Data consistency means that the cache memory can sometimes cause problems with data consistency, as the data in the cache may not always be up to date with the data in main memory. This can lead to inconsistencies and errors in the system. Last but not least is the cache trashing. If the cache is not managed efficiently, it can become full of data that is no longer needed or accessed infrequently. This is known as cache trashing and can lead to decreased performance as the cache become less effective at reducing the number of accesses to main memory.
Okay, for the conclusion, in a computer system, cache memory is sort of a high-speed memory that is used to store data in instructions that are often accessed. Because it is faster than main memory and it's situated on the processor's chip, it can enhance system performance by lowering the amount of access to main memory. Improve performance, shortened memory access time, higher memory capacity, energy efficiency, and cost effectiveness are just a few benefits of cache memory. It does, however, have significant drawbacks such as restricted capacity, complexity, problems with data consistency, and the risk for cache crashing. The design and performance optimization of computer system must consider cache memory. Thank you.